Identify the ROC associated with the given Z transform equation. X of n equals to minus of n u of minus n minus 1 plus 2 into 1 by 4 n u of n. See, from the given sequence x of n, it is a two-sided sequence. Means the ROC is kind of a ring. Here, see, x of n we can write as sum of two signals, which is x1 of n plus x2 of n. Whereas x1 of n is left-sided signal, whereas x2 of n is the right-sided signal. Means here the ROC of x1 of z is mod z less than half, whereas ROC associated with the x2 of z is mod z greater than 1 by 4. Hence option A is correct. Determine the Laplace transform and ROC for the given anti-causal signal minus e power at u of minus t. Here the Laplace transform, suppose f of t equals to e power at u of minus t. F of s is given as integration from minus infinite to infinite f of t e power minus st dt. So minus infinite to infinite e power at u of minus t e power minus st dt. Here 0 to infinite e power s minus a t dt. The integration converges to finite value if and only if the real part of s minus a is less than 0. That means f of s equals to minus 1 by plus 1 by s by if and only if real part of s less than a. Hence the option C is correct.
Power factor of a three-phase full-wave converter is more than that of a three-phase semi-converter. Okay. Now he has given a question like that. So what is the answer for this one? Okay. If you see three-phase full-wave converter, the output average voltage, this is V0, will be in positive area and in negative area. What does it mean? That average output voltage is less. Okay. What about semi-converter? V0, this is for full wave and this is for semi-converter. For semi-converter, output voltage is always positive. Okay. When compared to full wave, V0 semi-converter will be more than that of V0 full wave. I am talking about average output voltage. Okay. Now average output voltage semi-converter is more. If average output voltage is more, what about power delivered? Power delivered using semi-converter will be more than that of a full wave, or you can write the relation like this. If power delivered is more, power factor will be more in semi-converter when compared to that of cos phi of full wave converter. Okay. So which one is correct here? The above statement is false. First option, if you see, the above statement is false because the converter power factor is less than that of semi-converter. Full wave converter power factor is less than that of semi-converter. Option B is wrong and option D is also wrong. Look at the interesting one is option C there. It depends on firing angle alpha. Okay, this is true only when alpha is equal to 0 degrees. At alpha is equal to 0 degrees, cos phi of semi-converter is equal to power factor, that is cos phi of full wave converter. But in general statement, option A is correct. Okay, option C is correct only when alpha is equal to 0 degrees. But when you use converters here, what is our main aim? We have to control the output voltage. Okay, that means we have to control the power delivered to the load. So if you take in general statement, option A is correct. The above statement is false.
Question is, for the network shown in the figure, the initial charge on the capacitor and the current in the inductor are 0. The minimum time after the switches are closed at t equals to 0, at which voltages Vx becomes to 0. Here, the given data is IL of 0 equals to 0, Vc of 0 equals to 0. Here Vx equals to VL minus Vc. Here IL equals to IL of infinity plus IL of 0 minus IL of infinity into e power minus R by L into t. If we write the equation, this is IL. VL equals to L dIL by dt, which is equals to 100 e power minus 1000 t. Similarly, Vc of t equals to 100 of 1 minus e power 1000 t. If we equate Vc equals to VL, then we will get t equals to 0.693 milliseconds. Hence option C is correct. Here the question is, in the figure given, assume that the diode and the op-amp are ideal. For Vi varying from +1 to -1, the output voltage V0 will vary from. Here in the given figure, the circuit acts as a inverting amplifier, means there is a 180 degrees phase shift between the V0 and the Vi. So suppose Vi is varying from +1 means -1 to +1, means we can divide into two parts, that is Vi varying from -1 to 0 and 0 to +1. Whenever Vi is negative, output is positive. Vi is positive, output is negative. So in case 1 Vi is negative, suppose whenever Vi is negative, that means -1 to 0, V0 is positive. Positive means the diode is going to be reverse bias, which is going to act as a open circuit. In that case, V0 equals to -4 by 1 into, this is the case for Vi is negative, that is equals to +4 volts when Vi equals to -1. Similarly, V0 equals to -2 by 1, input is +1, that is equals to -2 volts when Vi equals to +1. That means Vi varies from -2 to +4 volts. Hence option B is correct.